So we have a 2,000 kilogram car. We're told that two forces are acting on it. What does it say here? 2,000 kilogram car moves down a level highway under the actions of two forces. So hey, let's do a free body diagram. Free body diagram, so just so we can see everything. So we have mg down. We have normal force up because it's on a surface. We have, they tell us here, we have a 1,000 Newton forward force. So we have a force that's forward, that's 1,000, and then we have a resistive force, like a frictional force, of 950. Okay? So those are the forces acting on the car. Of those four forces, how many are doing work? Only two. This guy's doing work, and this guy's doing work, right? Remember, what's the sign convention for work? In the direction of motion is plus, opposite motion is minus. So the work done by this force is going to be positive work. The work done by this force will be negative work, okay? Now look, could we figure this question out using last chapter? Yeah, you totally could have. Like, what you could do is you could sum the forces in the x direction, because the thing they want us to find, when the car is over here, what's the velocity? How fast is it going? So what you could do, you sum the forces in the x direction, 1,000 newtons minus 950 equals ma. From there, what could you get? A. And then plug into a kinematic, and you're good. Well, look, are we in chapter 4 here? No. This is chapter 5, so let's do it the new way. The new way to do it, and you got to be able to do problems both ways, because on the AP test, they'll tell you which way they want. If they say to solve this with energy, they want it done with energy. So look, the equation to use here is net work. The total work done on an object is always equal to the change of kinetic. Okay? So what could we say about this net work? What's the basic work equation? The basic work equation is F times what? Delta X. It's force times displacement. And the 20 meters, that's the displacement. Okay? So what's change of kinetic going to be? Change of kinetic is going to be kinetic final minus kinetic initial. But look what they say right here. It starts from rest. So what's the initial kinetic? 0. Okay, so what we're left with is, and this should be F net, right? If you're talking about work net, then this is F net. You guys got that? If you're talking about net work, then in this equation here, it has to be net force. Okay? What is the net force acting on the car? 50 newtons. If you look at this here, we have 1,000 newtons to the right and 950 to the left. 1,000 to the right and 950 to the left. What does that simplify to? 50 to the right. The net force on the car is 50 newtons, right? 1,000 and 950 simplify to 50. Okay? So here we go. We have net force times the displacement, that's the work equation, equals 1/2 mv final squared. What's the only thing missing in this equation? V final. So V final is going to be equal to 2 times the net force times the displacement divided by m square rooted. So I'm going to plug the numbers in over here. So that'll be V final square root 2 times 50 newtons times the displacement of 20 meters over the mass, which is 2,000 kilograms. This comes out to be 1 meter per second. So this guy is really pissing off other people. It took him 20 meters. It took him 20 meters to go from 0 to 1 meter per second. So he's like, putt, 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 putt. People are behind him like, honking. All right. Does this make sense?